Today we will be discussing the 2025 updates to the SB 2030 Energy Standard. SB 2030 is short for Sustainable Building 2030 and is modeled off of the Architecture 2030 program. The structure of this program is to establish increasingly stringent energy use targets for projects, these targets shifting downwards every 5 years. The program holds these increasing reductions from a consistent baseline, using typical building energy use in 2003. In 2025, this target shifted to the 2025 SB 2030 standard, which requires a 90% reduction from that 2003 average building baseline. Although modeled after this Architecture 2030 program, SB 2030 has been customized to be implementable in Minnesota across a wide variety of project types, reflecting the range of buildings that come through the program. SB 2030 is generally required for new construction and major renovation building projects that are state general obligation bond funded, although some municipalities and other entities require projects that they fund to also meet these SB 2030 targets. Our general suggestion to project teams is to inquire whether SB 2030 applies anytime public dollars are in or have the potential to be in a project's budget. The version of the program that you're required to meet is based on the start date of the schematic design phase of the project. As of January 1, 2025, we updated the program. Some of these key updates I will outline here today, reflecting a shift to a set of more stringent program requirements. So, moving from December 31st of 2024 to January 1st of 2025 shifts the rule set that projects would use. The SB 2030 program fits within a larger network of B3 programs that come into play during different moments in a project's lifespan. Shown here is the B3 guidelines and SB 2030 programs in pre-design through construction where the projects set sustainability goals that need to be met. In operations, a somewhat different suite of tools comes into play, where we have the B3 benchmarking program and post-occupancy evaluation programs, which come in and be informative about the building in operation and ensure that it's meeting its targets that were set during design and construction. As we are specifically talking about SB 2030 today, I'm not going to spend much time on the overall B3 program, but just to note that this fits within a larger kit of tools. Highlighted here are a few key considerations around meeting SB 2030 target when setting the budget during the pre-design. As we move into 2025 standard, it is increasingly important to understand early in the process what systems are needed to achieve these targets and that those systems are being put into project budgets. There may be systems involved that may not have been considered before these updates. With that noted, in pre-design, a project should be able to set its energy target and have some idea about what systems are going to be needed to meet that target. During design, this gets integrated into the design of the project, and project teams are performing iterative energy modeling to make sure that they're still expecting to hit this target as the design of the building progresses. We understand the design of the project does shift over time and want to make sure that project teams are maintaining a reference to these targets so when the project is complete during construction, it's still able to achieve its goals. During operation, ongoing data is tracked through the B3 benchmarking program to ensure the project is continuing to achieve the energy target that was developed during the design process, in part because if not, that could indicate that something is operating suboptimally in the building and could be used to identify an opportunity for the project to actualize the desired performance and the designed performance. There's a couple of tools that help in this effort, and I'll show the primary three here. In the upper left is the B3 Guidelines Tracking Tool, which, if you've worked in a B3 project before, you are likely familiar with. This tool is essentially an online file where we can track all of the data coming from the project team. The Energy Standard tool is embedded within this tracking tool, shown here at the upper right. This is the mechanism by which you set your energy target and also can model your design to compare it to the energy target and evaluate different energy savings measures. The tool shown in the lower left here is the B3 benchmarking platform, and that is for buildings in operation to be able to track their energy and water use. This also provides a lot of analytics of energy use and potential energy savings opportunities. For projects working through the SB 2030 program, we can use these tools in the design process to be able to verify that the projects are coming through the program are actually hitting their targets in operation. An important consideration, and one that's actually written into the legislation of SB 2030, is that we need to have considered cost effectiveness in the implementation of the program. So essentially, we have two considerations that are managed as part of this effort. One is achieving increasing energy savings targets, and two, doing so in a way that considers cost effectiveness. Prior to 2025, this cost-effective limits were based on how different utility conservation measures looked at against a societal test, a participant test, and a utility test, which are kind of fancy terms for how utility programs are asked to think about their cost-effectiveness of their programs. We took these and ran a variety of example measures against them in order to give project teams a way to approach cost-effectiveness at the project level and at the measure level. Prior to 2025, this analysis indicated that a simple payback of 12 years or less was considered under the program to be cost-effective. Prior to 2025, this was the cost-effective test for all measures under the program, though note that this cost-effective test has been updated for the 90% better version of the program. Prior program updates introduced the option of bringing in renewable energy from off of the project site. This option is available if the project team could show that they had first exhausted cost-effective energy savings opportunities and renewable energy generation opportunities that are present on the project site. Along with the inclusion of these off-site resources, a hierarchy of renewable options was developed, where project teams would look first at what was available on the project site. Then, after exhausting what cost-effective options are present on the project site or campus, would look to what was available in their larger portfolio. An example for state agencies could look like the DNR using a portion of a potentially more cost-effective larger PV array at a different location to offset the energy use of the building that they are putting online. If there's no in-portfolio availability of offsite resources, then the project would need to look at other market products like renewable energy certificates or RECs or other offsite non-portfolio measures. So the result of this is that there are multiple potential paths that can come to bear in order to help a project meet SB 2030, customized here to the specific opportunities of each project. Shown here is a sketch of a project moving through the program prior to the 2025 updates. The bar on the left shows that 2003 average building with the 80% reduction requirement that was enforced for projects between 2020 and 2024. So that number is essentially the energy budget for the project. The second bar shown here represents the code and measures better than code, which gets you part of the way to the target. Moving to the right, we see on-site renewables and off-site measures then being included to get the project to the target. As part of this, we established something that's called an on-site target that essentially notes the extent to which the target can be met with measures on the project site or greater campus. So this is kind of stepping towards fully meeting that target. I'll also make note that importantly, if you're working on one of these projects and you've identified that you need to set an on-site target, to have that discussion with our SB 2030 review team as soon as that's identified. So we can make sure that we're all on the same page with what resources or what measures are being included in the design of these projects. So there's several different pathways that emerge as projects meet SB 2030 based on what opportunities are present on the project site. Shown here, if you can just fully meet it using only efficiency measures. For the pre-2025 80% better thresholds, this is close to a passive house level of performance where you're cranking really, really hard on the efficiency side of things, but not needing to include renewable energy. As we move from the 80% better to the 90% better projects, we expect that all projects will need some mixture of efficiency and renewable energy, either on-site, off-site, or a combination of both, in order to fully meet the target. Now shown here is a project that is meeting its target with some on-site resources and some off-site resources. In particular, some on-site renewables and some renewable energy certificates. I'll reiterate that what's been shown so far was the status of the program up into the 2025 updates. So under SB 2030, there's a hierarchical approach where projects would first look at what opportunities are available on the project site, then to what is available in the larger portfolio of the project, then to the purchase of renewable energy. With the 2025 program updates, this overall structure remains the same, but there's a couple of key and notable changes that shift as we moved into 2025. These are outlined here along with the driver for each. The SB 2030 program is directed by the establishing legislation to look to the utility program's approach to cost effectiveness, and any changes to that approach would then flow down to the SB 2030 program. These utility rules were shifted by the ECO Act in 2021, which changed the way that we looked at cost effectiveness under our program. This shifted the program from looking at this using primarily a societal viewpoint to using a participant viewpoint. I'll go through some more detail in a little bit about what that shift entails. The second key driver that we now have is that we now have access to a lot better forecasts of emissions rates for electricity. So essentially a better idea about the expected electricity emissions that we're going to see across the lifespan of these buildings. As part of these updates, we are shifting our carbon accounting to those forward-looking utility emissions rates instead of current or past rates. And the last key update I'll note today is that we've seen an emerging consensus on several similar programs which are either code advancement or net zero efforts on how to treat or count unbundled renewable energy certificates and how they can be used to offset energy use of a project. Part of the 2025 update is alignment with this emerging consensus. On cost effectiveness, we discussed how up until 2025 we used this 12-year simple payback for all measures, but there's understandably some limitations in that approach that we've seen as we worked through this evaluation on projects. So as part of the shift to 2025, the rules, we are moving to using a more nuanced application of a cost-effective window, which will now apply a different simple payback evaluation depending on the expected life of the measure itself. So for example, if there's a measure like wall insulation that is going to last a lot longer than a lighting control package, this payback analysis would take that measure life into account when establishing the payback periods for those measure categories. The expected impact of this is to see more of those longer life measures as coming in as cost effective and being needed to be included in the project. As we are moving to this participant test approach, we are also now asking projects to include federal incentives, if available, in those cost calculations for systems that have those incentives. So as part of that update, notably solar, geothermal, when available, and some heat pump rebates should be included as part of that evaluation, because that's really the cost the project is actually going to be seeing as we move to this participant test framework. This is further expected to increase the likelihood that those measures with federal incentives are included in projects. In addition to the inclusion of these federal incentives, we are also asking project teams to account for meter charges that relate in particular to natural gas hookups, because we found that that actually drives the ongoing cost of the occupants. This is particularly true in multifamily housing, where a large piece of the overall energy budget of these projects is the meter charge for the large number of natural gas connections, which is one per unit in a typical build-out. Moving forward, this charge does need to be considered as part of the cost for these projects because that can be impactful in how these cost tests play out again as we move to this participant test model. Now shown here is a table of these measure lives and the different applicable payback windows. As you can see, we aren't splitting these up into individual strategies, but rather into groups of measures with similar expected measure lives. This does vary between measures such as lighting, water heaters, and shower heads, which would use a simple payback test of 9 years, all the way to building envelope improvements, which are tested against a 24-year simple payback window. A key update to highlight is that the on-site renewables now look at a 20-year simple payback, and that cost would be after federal incentives if available. Because of this shift, we are much more likely to see these on-site renewable systems as penciling out as being required under the program because of this shift to participant-based cost testing. Another key update to note is that for unbundled renewable energy certificates, which are essentially credits for renewable energy production elsewhere, these will now have a procurement factor applied. So if you have to use RECs to meet your SB 2030 target, these will now have a 5-to-1 multiplier, needing 5 times as many RECs than if a different kind of renewable energy source is being used. This update brings the SB 2030 program in line with other programs and how they treat these unbundled RECs. Though these RECs will have this procurement factor applied, I would like to emphasize that there are a variety of other off-site renewable options that can be used without this factor, as this is most closely aligned with the definitions found in the 2024 IECC. If you're looking for a definition for what these different off-site options are, that's the place we would suggest starting your search. So this brings us back to look at what a project would need in order to hit a 90% better target. The program is still looking at several different sources coming into play in order to meet these targets and continuing to apply a hierarchical approach, where the site is looked at first, then the larger portfolio of the project, then to the market. As the program moves from an 80% better to a 90% better, we're expected to see both more efficient buildings and more on-site renewable energy development because of the modified payback evaluation and now the inclusion of federal incentives. Also, we expect more consideration of a broader variety of off-site renewable energy options due to the increasingly aggressive targets and the application of a procurement factor to unbundled RECs. The last key update that I will touch on is the program is moving to using future marginal electric carbon emissions factors rather than current carbon emissions factors. This change will better score buildings during design against their expected emissions during operations, based on best available estimates for how the grid will be built out. And in order to not penalize a project that might be electrifying, by using the future grid rates rather than the current grid rates to better match their expected emissions during their lifespan. So to wrap up, here are a few takeaways. The SB 2030 program is continuing to ask projects to step through an on- and off-site resource evaluation. The 2025 updates are expected to prioritize longer life energy conservation measures and on-site renewable energy opportunities, in particular those that have federal incentives associated with them. The application of a procurement factor for unbundled RECs is expected to see an increased interest in alternative off-site approaches, and the barrier to electrification with the SB 2030 carbon standard has been lowered by now looking at future marginal emissions rates rather than historic grid averages. As a final note, these updates are listed in a white paper entitled Moving to 2025, which is posted at our website at b3mn.org if you're interested in reading more on these changes. Please direct any questions to guidelines@b3mn.org, and thank you for your time.